Okay, so let us now read the question statement for question 3. Like I mentioned, this is the question on projectile motion. They're saying that a small ball is dropped from a height of 2 meters. Here's my thing. I apologize. And bounces a few times after landing on a cement floor. And we are told to ignore the effects of air friction. Then we are given a time position graph below. It is not drawn to scale. That represents the motion of this ball that they are talking about. So we see, okay, this ball is dropped from a height of 2, because the y-axis is position measured in meters, the x-axis is time measured in seconds. Position is dropped there, goes down after 0.64 seconds, it hits the floor, and then it's in contact with the floor for a couple of seconds there before bouncing for the first time, reaches a maximum height there, then comes down again, hits the floor after 1.9 seconds since the beginning, and then is in contact with the floor. Same thing happened when it bounces, which is that maximum height, and finally it hits the floor at a time t, which is not provided for us. So now let us see. And then the first question, the definition question. Normally this is how questions are structured. We have to define the term free fall. Then question 3.2, we have to use the graph to determine each of the following things that they're asking us. So question 3.2.1 says the time that the ball is in contact with the floor before the first bounce. Okay, the time that it takes the ball to reach its maximum height after the first bounce, and then the speed with which the ball leaves the floor with at the first bounce. And then a question that weighs a lot there would be that the time t indicated on the graph, like I mentioned, that time was not provided for us. So yeah, let us just jump straight into it and try to solve this and see what are some of the important things that we're gonna take away from it. Let us now answer question 3. So remember, in question 3 we're given a position time graph. This means that on the y-axis we have position measured in meters, important to take note of that, and the time measured in seconds. This is on the y-axis, and then we have a ball that is dropped from a height of 2 meters. Let's call this position A. Then it travels down, and then after 0.64 seconds it hits the floor, so let's call this position B, and then it's in contact with the floor for a little while, and then finally leaves towards its first bounce at 0.67 seconds. Here it reaches a maximum height at D. Let us call that D, and then reaches maximum height, travels down again, hits the floor at 1.90 seconds. Let us call this position C, and then it's in contact with the floor for a little while, and then travels back up, bounces back up, and then reaches a maximum height. So EF at G reaches a maximum height, then finally hits the floor there at a time T. So the one thing that also we have to do after labeling all of this important position is to determine the direction. So let us say we'll decide that up is positive and then down is negative. It can be the other way around, it doesn't matter. So let us now go straight to the first question. This first question is always in this case is quite simple because it's a matter of definition. I think question 3.1 requires us to define the term free fall. So the marks for this is 2. This is the easy marks. Please understand and know your definitions very well. And free fall, the standard definition is that it's a motion of an object under the influence of gravity or weight alone or weight only. So it's the motion of an object under the influence of weight or gravity alone. Okay, so understand those definitions so that you can score those easy marks. And then question 3.2, it says use the graph and determine the following. So now we have to use the graph and answer the following questions. And then question 3.1 says the time that the ball is in contact with the floor before the first bounce. So this part is the first bounce, and this part is the second bounce. So let's do that again. Dropped from a height of 2 meters after 0.64 seconds, hits the floor, it's in contact with the floor for a little while. So we actually have to find the time that this object is in contact with the floor. So we can just say, okay, a change in T will be just the final time. This is with the time that it leaves just before it bounces back, and then the time that it actually hit the floor, the initial time. So TF in this case is 0.67 because this is when it is about to have to bounce back up and then it hit the floor at 0.64. So this is just a math. This is going to give us a value of 0.03 seconds. And now we have answered that question and you have found yourself 2 marks. Now let us move on to the next question, which is question 3.2.2. So it says to us the time it takes the ball to reach its maximum height after the first bounce. So this is the first bounce, and then it wants us the time it takes for this ball from here to reach the maximum height. So this is max height. How do we spell that? This is the maximum height as well there. So they want this time. How do you think we're going to do this? The max for this is 2. So that also tells you that it's not going to be a lengthy calculation. So how long do you think it takes for this ball to reach its maximum height after the first bounce? To do this, I would say we just say, okay, let's just find the change in time between position E and C. So C and E, let's find the change in time. Because remember, the change in time, TF final time minus initial time. So the change in the final before when it hits the floor again is going to be 1.90 minus 0.67. How much is that when we put it? Here's my calculator. So that is a value of 1.9. So this is my calculator is taking a while to come. Clear everything. 1.90 minus 0.7. 0.67. So that is 1.23 seconds. You guys are just going to have to confirm with me. But then what do we know about projectile motion? We know that this graph, even though it doesn't look symmetric because I cannot draw to save my life, it's actually symmetric. This means the time it takes for this ball to move from here to here is also the time it will take for this ball to move from the maximum height to this position, to the initial position. So that is why the first thing I did was to find this time, and then I will know it reached this time here right in the middle. So the change in, I'm gonna just take that change in time. So the time to reach, max height, so that will be equals to 1.23 divided by 2. So that we do that, if we divide everything by 2, it gives us a value of 0.615 seconds. So this means that this ball, after bouncing back up, it takes 0.615 seconds to reach the maximum height of the first bounce. Hope that makes sense. So let us now move on to I'm not sure which question we are on now, to question 3.2.3. So this took 0, I just want to write this 0.615 seconds. So now I just wanted to move here to there. So question 3.2.3. Let's do it quickly. It's not a long question, so we should not spend way too much time on it. So it says the speed at which the ball leaves the floor at the first bounce. So we know the time that it leaves the floor is at 0.67. We know that it takes 0.615 seconds for it to reach the maximum height. So now they're talking about the speed. We have to determine the speed. How on earth do we do that? So to do that, let us now remember our favorite equations, which are equations of motion. So let me just write them. If you have forgotten, we have VF equals to VI plus G change in TG, because we're talking about free fall. We're talking about projectile motion. A VF squared plus VI squared plus 2G change in Y because we're dealing with the Y-axis. And then we have our change in Y equals to VI change in T plus 1 over 2G change in T squared. You can find this at the back of your question paper. It will be given to you when you're writing your paper 1 exam. So you're writing your trials tomorrow. So yeah, let us do this quickly. So we have these equations of motions, and we have adapted them for the Y direction as well as free fall motion or projectile motion. So now we have to say, okay, how on earth do we find the speed here, the initial speed that the ball bounced back at. To do that, we say, okay, just take this portion and only focus between C and D. So our focus is between C and D. And try to identify the quantities that we already know, the physical quantities that we already know. Let us see. Do we know the final velocity, VF? Yes, we do, because we know at maximum height, the final velocity is going to be 0 meters per second. Do we know the initial velocity? Absolutely not. That is what we're trying to determine. So this is the velocity, the speed. I keep saying velocity, the speed that this ball left, the ball left the ground with. We don't know it. That is what we're trying to determine. Do we know the G? Yes, we know G. We always know that the value of G is 9.8 multiplied by 9.8 meters per second squared. And then it's always acting down because it's projectile motion, and we chose the downward direction to be negative, so we put a negative there. What else do we know? The change in time. So the time it takes for this ball to from the floor to reach this maximum height. Yes, we do. We calculated that in the previous question. We found it to be 0.51 seconds. What else can we do? We know the change in the displacement. Yes, we do, because we know that this ball moved from position 0, initial position, to the final position. So YF minus Y initial. So our Y final position is 1.85. Ooh, that's not in. So that's one. That's one point. So the change in Y. Let me start that again. The change in Y is going to be YF minus YI, and YF is 1.85. because this ball bounces back and reaches a height of 1.85 meters minus the initial, which is 0, so that is just 1.85 meters. Cool, understandable. And okay, what else do we know? I think we are just about enough. Now we have to look for an equation that we can use to find the value of VI that has, so we have all the physical quantities at most except for this one. So let us check. Can we use this one, this one, this one, this one? Because it seems like we have most of them, I would suggest that you pick the first one. It's easier to work with. So let us say VF equals to VI plus G change in T. You can use any. You can use this one because you have G of the change in Y, and then you find this. You can also use this one. You have all the everything that you need. But if you look at it, it will be much easier to work with this equation. Hence, I chose it. Always finding easier ways to do things. The final velocity, we said it's 0. The initial velocity, that is what we're trying to determine. G, we said it's negative 9.8 meters because it's acting down, and we selected down as negative, our downward motion to be negative. And then what else? The change in T, we said that ball takes 0.615 seconds to move from position C to D from our schematic. And then now we just, okay, VI, initial velocity. Let me just do this on my calculator very quickly. So that is negative of, how do I clear this? Okay, a negative of 9.8 multiplied by 0.615. 615. So that gives us let me move this. So that gives us negative 6.027, and this is 0. So if I take this to the other side, you notice that the sign is going to change. So we'll be left with 6.027 meters per second, which is equals to VI. So now we have actually can just say therefore the speed at which the ball bounces off the floor for the first time is actually 6.027 meters per second. So we have found that speed. Let me just write this value. I don't know if I'm gonna need it, but yeah, 0.6.027 meters per second. I'm hoping that makes sense. So now let us try to move on to another question. So that is the question 3.2.4. So question 3.2.4, I'm not going to remove these equations. I'm just going to wipe this part. So question 3.2.4 says to us, find the time t indicated on the graph, and the marks are 6. So 6 marks. So you have to find this time. Remember, it was not given to us. We have to find it. How do you think we can do it? So let us say, to do that, let us say we move, let us only consider these 2 points, the maximum height during the second bounce as well as that time when it hits the floor after the second bounce. And so we only concerned with that motion between G and, wait, so we call this H, right? So FGH, between G and H. And we do the same dance that we did before. Let us find out what is it that we know. Which physical quantities do we know the values of between these two positions, right? Okay, do we know the initial velocity? Yes, we do. It is 0 meters per second because the velocity or the speed there at the maximum height is given by a value of 0 meters per second. It's always 0 at the maximum height. Do we know the final velocity, the final speed? Nope, we don't know it. Do we know the change in y? The change, so that is the displacement, which is going to be given to us by yf minus y initial. So the final yf would be 0 minus y initial. So the maximum height was at 1.2. So this is going to give us a value of a negative 1.2. So I'm going to remove everything that I just did here and say it's going to be a negative 1.2. It's a negative because from G to H, it's moving down. And we said that downward motion is negative. So hence we have a negative 1,2 meters. Do we know G? Yes, it's 9.8 and it's always acting downwards. And we said downward is negative. What else? Do we know the change in time? Do we know the change in time? No, we don't know the change in time. What else do we need to know for this question? So I'm just trying to think now. So let us now. So we see that we don't know two things, two variables. Yes, we don't know two physical quantities. We don't know the change in time. We don't know the change in the final velocity, which is, no, that is not necessarily what we're trying to find out. We're trying to find out the time here. So we don't know two things. So let us go back to our equations and try to determine at least the final velocity. So we have to look for an equation that will not require us to have the change in t. So that equation that won't require us to have change in t, but we can find the final velocity, is this equation. So we use that equation to find the final velocity. Hope that makes sense. So we have change in y equals to vi plus vf divided by 2. This can be a change in y. What? Oh no. This is a change in t. I am just lying right now. It's actually a change in t. So I am actually lying. So the equation that won't actually, because I'm realizing, man, that this doesn't make sense. This is actually a change in t. So the equation that doesn't require a change in t is this one, and we can find the final velocity. So you say vf squared. I apologize for that, but I'm sure you guys picked it up, so that's good. G change in y. So we know the initial velocity to be 0 plus, remember this is squared, 2, we said it's negative of 9.8, and then we said the displacement would be a negative of 1.2. 0 squared is 0, 2 multiplied, let me just put this on the calculator quickly. If we put that on a calculator, it's going to give us 23,52. This is a squared, so to be left with VF, we have to introduce a square root on both sides. So we have 23,52. So let us see how much. And if we do that, we find that VF actually equals to plus or minus, because it's a square root, we have to say plus or minus 23. No, I'm lying, 4,85 meters per second. It's moving down. So our speed there is going to be 4.85 meters per second. So that is 4.85 meters per second. And because it's actually the ball is moving down, let me me just write this. Here is going to be a negative of 4.85 meters per second. So this is the speed, or this is the velocity that, to just quickly, the ball hit the floor with here, but we're actually looking for the change in time. So now we can now go back to our initial equation. We see we have VF, we have VI, we have G, we have and we're looking for that change in time. So we say, okay, VF, we said it's a negative, so let me do this properly. VF is equals to VI plus G, change in T. Final velocity said it's a minus of 4.85 equals to 0 plus a negative of 9.8, and then just this entire field multiplied by a change in T. And then it's just a matter of so we have a negative 4.85, which is equals to a negative of 9.8 change in T. To be left with change in T, we simply divide both sides by 9.8 divided by negative 9.8. A negative divided by a negative is going to give us a positive, so these two will cancel, and then we have a situation. I'm trying to see where can I write now. So we have now a situation where we say, okay, negative 4.8 divided by negative 9.8, put that on our calculator, and if we do that, we find that the change in T is equals to 0.49 seconds. But we're not looking for the change in time. I'm just going to remove this. So now we have found the change in time to be 0.49 seconds. That's not a 5, that's a second. 0.49 seconds. So remember, we're not looking for the change in time, we're looking for this time here. So they're saying that from G, you see, from G, position G to here, the time is 0.49 seconds. But what do we know? That the time from here to here is also going to be the time from here to here. So this is also going to be 0.49, meaning the total time from here to here is going to be just the sum of that. So the total time, the change in time between F to H is actually just going to be the total time is just going to be 0.49 plus 0.49. And then we find that that time is going to be so that change in time is going to be from between these two positions going to be 0.98. But we're still not looking for the change in time between F and H. We're not looking for the change in time between F and H. We are actually looking for this time here. So we know here at F we have 1.97. And then if the change in time between these two positions is 0.95, this means to find this time, we just have to say 1.97 plus 0.95. So T is just going to be 1.97 plus our change in time, which we found to be 0.95. And let's put this on our calculator. So I'm realizing that I kept saying it's 0.95. It's actually 0.98 because 0.49 plus 0.49, 0.495 plus 0.495 will give us 0.98. So you can just check that on your calculator again. So 0.49, 0.49 plus 0.49. I think my brain is getting tired at this point. So that is, yes, 0.98. So meaning to find the time T, we have to say 1.97 plus 0.98, which will give us a value of 2.95, if I'm not mistaken. So meaning this time here, this ball reaches the floor after the second bounce after 2.95 seconds. And yeah, I assume, let me check, that this brings us to the end of question 3.